Find the partial fraction decomposition of the rational function x to the fourth plus x cubed plus x squared minus x plus 1 over the quantity x times x squared plus 1 squared. Observe that the degree in the numerator is 4, and the degree in the denominator is 1 plus 4, which is 5. X squared is x to the fourth times x is x to the fifth. And so this is the proper fraction because the degree in the numerator is strictly less than the degree in the denominator. In the denominator, we see that there is a linear factor x and an irreducible quadratic x squared plus 1 because x squared plus 1 can never be 0. And also, this irreducible quadratic factor is being repeated 2 times. The first step is to set up the form of the partial fraction decomposition. The factor x has the coefficient of a on top. The factor x squared plus 1, which is an irreducible quadratic, has a factor mx plus b linear. We already used the capital letter A, so this time we would need to use bx plus c linear. And since the factor x squared plus 1 is being repeated, we would need to use this again, but we can't just simply use x squared plus 1. We would need to square this. We still treat this as a quadratic factor, so the top is still linear, dx plus e. To determine the coefficients a, b, c, d, e, we will need to combine the simpler fraction with the least common denominator of x times x squared plus 1 squared. We will need to multiply the first simpler fraction with x squared plus 1, the quantity square, both in the numerator and the denominator. For this second simpler fraction, we would need to multiply x and also x squared plus 1 because we need 2 factors of x squared plus 1. And for the last simpler fraction, we would need to multiply x only. Simplifying and distribute, we have a times x to the fourth plus 2x squared plus 1 plus, we distribute the x first, bx squared plus cx times x squared plus 1 plus, we distribute the x to get dx squared plus ex. And then distribute this further, ax to the fourth plus 2ax squared plus a plus, and then we FOIL this, bx to the fourth plus bx squared plus cx cubed plus cx plus dx squared plus ex over the least common denominator, which is x times x squared plus 1, the quantity squared. This needs to be the same as the given rational expression, which is x to the fourth plus x cubed plus x squared minus x plus 1 over the same denominator, x times x squared plus 1 squared. For these two fractions to be the same, we have the same denominators already. Therefore, we must have the same numerators. X to the fourth plus x cubed plus x squared minus x plus 1 equals, we group the like terms, ax to the fourth plus bx to the fourth, and then plus cx cubed. Next, the x squared terms, 2ax squared plus bx squared plus dx squared, and there are 3 of them. And then the x terms, they are cx plus ex, and the constant term a only. Comparing the coefficients, we must have 1 x to the fourth equals a plus b. The coefficient of x to the fourth on the right hand side is a plus b. 1x cubed need to be the same as cx cubed. So c equals 1. 1x squared must be the same as 2a plus b plus d. 2a, b, d are the coefficient of x squared on the right hand side. -1 equals c plus e. C and e are the coefficient of x on the right hand side. And 1 equals a. The only constant term on the right hand side is a. Because of this, we have a equals 1, and from the first equation, if a equals 1, then b equals 0. We already have c equals 1. If c equals 1, then e equals -1 minus 1 is -2 because c equals 1. And if a equals 1, b equals 0, then d is 1 minus 2, so d equals -1. Thus, the given rational expression can be written in the form a over x, but a is 1, plus bx plus c, but b is 0 and c is 1, over x squared plus 1, plus dx plus e, d is -1, x plus e is -2, over x squared plus 1, the quantity squared. And simplifying this, we have 1 over x plus 1 over x squared plus 1 minus x plus 2, where we factor out the -1 in the numerator, over x squared plus 1, the quantity squared.